Alrighty, it's recording, so we should begin. Alrighty, hello everyone. Welcome back to day 4, I believe, of this learning from scratch Python course. Today we will be looking at a new concept in Python, and we will also be looking at the answers from yesterday's challenge. So all our webinars will be recorded and uploaded to YouTube afterwards. So I also do have the chat open, so if someone does send me a message, I will be able to see it. Hence, we recommend you tune in live. If you do have any questions, you could ask and hopefully get them answered. That being said, let me share my screen. There we go. Let's minimize this. Yeah, hopefully you should be able to hear me. And it's recording. Cool. So as I said yesterday, I had given you, I think it was this challenge. Yesterday I had given you this other challenge. So yesterday we did look at how to take information from the user and how to convert between data types. So if you don't have zero idea what I just said, do have a look at yesterday's and the days before's audio. There is no audio. Let's see, microphone.
Hopefully I fixed it now. Don't know why that was changed. Can you hear me now? Hopefully you could hear me now. So I'll re-say everything I just said. So hi guys, yeah, welcome back to day 4, I believe, of this Python Learning from Scratch webinar. Yesterday we went over how to take inputs from users and how to convert between data types. If you have zero idea what I'm talking about, then I advise you to go back to yesterday's and the days before's webinar to kind of understand what we've done so far. So this is the 4th webinar, I believe. We started Sunday, Monday, Tuesday. Yep. So today is the 4th webinar. So the first webinar we looked at how to print. Second webinar we looked at data types and just get a general understanding of data types. Yesterday's webinar we looked at how to take information from the user and how to change between data types. So if you have no idea what I'm talking about, do go have a look at previous webinars. They are up on YouTube, on our YouTube page, on our YouTube channel, SB Components. They are up as videos around two-ish hours after this webinar ends. So at the end of yesterday's webinar, I did give this as a challenge. So after every major concept or idea, I will be giving you a challenge to kind of go away and practice in Python trying to make. So this was the challenge I gave yesterday, and the basic idea of this is make a program that takes in the length and width of a room, calculates this area. So obviously you give it to in centimeters, then it gives you the area in meters squared. It calculates extra wastage that you may need, which was, I believe, 10%. Yeah, 10%. And then it gives you the total area you kind of need to order. So if you do read through it carefully, write a program for a floorboard salesperson who they'll probably end up using this program for their work. This is a fairly simple program. You will run into errors that I did discuss yesterday. So for all the challenges I give you, you always kind of assume that the user enters correct values. I'll give you an example why. I'll kind of show you why in a second, again, if you don't remember from yesterday. But yes, I'll show you my code for this challenge. So let's, if this one to go away. There we go. Open it in desktop. Where is it? Desktop. Answers number 3. There we go. So this was my answer to this question that I kind of coded. So let's just quickly go over what it's supposed to do. So we're supposed to get the length and width of the room in centimeters from the user. We're supposed to calculate the areas then in meters squared. So that's just testing you A, on your maths, and B, like doing maths in Python. We did kind of go over this yesterday as well, how to do maths and play around with numbers in Python. The extra, so calculate the wastage, which is just some 10% more math stuff, and the total flooring area needed, which is just the area plus wastage to one decimal place. So that's another thing. So this is kind of what I came up with. You may have something completely different. That's the beauty of programming. You can make the same program in many different ways. The basic idea is that you enter these values and you roughly get these outputs. I say roughly because I found that round in Python sometimes works, sometimes doesn't work for me. So we'll get into this in a sec. But yeah, so today's session, after we go through this, we'll be improving this program slightly using comments and maybe methods. And afterwards, we'll look at if statements and how to do branching in Python. So that's the general plan for today. If we don't get any of it done, we'll continue on in tomorrow's webinar. So yeah, let's go through what I've done, why I did it the way I did, and the problems and the downsides and upsides of doing it the way I've done it. So first things first, we needed the length and the width from the user, which is pretty straightforward. If you attended yesterday's webinar, you use the input command to get some value from the user. Wait, let's quickly run this just so I show that it works. Let's use one of these examples. So let's do the bottom example, 1,000 and 520. And there we go. 52.0, 52.0, 5.2, 5.2. It's fairly straightforward. It's just the two lines I use to get the length and the width from the user. Things to note is my variable names are really good because it's clear if someone else were to come and look at my code, they would understand fairly easily what these variables are used for. If you give variables random names, that's not good. That's not a good programming practice. You should always give variables good names so people understand. So if someone else were to look at your code, they understand what these variables are used for. So length and width are what I use for my variable names, and they're equal to the input and to whatever the user enters, and whatever the user enters, I immediately then store it as an int. Now the reason I do it like this is the reason I immediately turn it into an int is later on I don't have to kind of keep track mentally if something's a string, if something's an integer, if something's a float. I immediately turn it into an int so that then later on, when I use length and width, I don't have to convert it there. I don't have to keep converting it. I convert it once. They're numbers. I know because I'm using them as length and width as like variable names, I know they're supposed to be numbers, and that's just a good practice. Another thing then, 1 second. I have 1 second. Sorry about that, I'm back. I just needed to quickly do something behind me because I could hear noise in the background. So hopefully that wasn't coming into the stream. So where was I? Yes. Okay. So that's what the first two lines do in this code. Now afterwards, we needed to calculate the area. Oh, why is my mouse freaking out? So next we needed to calculate the area. And that's fairly straightforward. If you read this carefully, it tells you how to do it if you're not sure how to do it maths-wise. So do know we ask the user in centimeters what the area is, and then we convert it to meters and calculate the area. Or you calculate the area, then turn it to meters. Whichever way you're more comfortable. The program does tell you one way of doing it. There are other ways. So it's fairly straightforward. Why is my mouse now freaking out? Cool, I'll just use this. So yeah, that's what this line does. So we have length times width, which is obviously just how you calculate the area, and then you divide it by 10,000 to get it in meters squared. That's a simple way of calculating the area. If you didn't know, you use stars for times and slashes for divide in Python and most other programming languages. We then have a print statement that just prints out the area. If you don't understand what's going on with this print statement, do check out the first webinar. We do kind of explain what these commas do and how to print information to the user in Python. Now, the next variable we call extra. It'll probably be better if we called it something like extra flooring or something, something along those lines. But if you change a variable once, so another thing with variables, if you change it, if you change a variable name once, you have to change everything else which uses that variable name. So if we do change extra hair, we have to change it then hair and then over hair. And for much bigger codes, it will be a lot worse. So the challenge does give you one way of calculating 10% of the area. I've pretty much done it the same way, just simplified it a little bit. So area times 0.1 will give you 10%. And then I print out what 10% is. I round it to 3 decimal places because if you kind of ran this first version, this ended up being 1.47200000002. So it just looks better, not required. Do note that I round it over here and I don't round it over here, just because if you just mathematically speaking, you shouldn't round while doing the calculations. You should round right at the end when you're displaying a final answer. So in like physics or maths, when you're doing calculations, you should just keep them to whatever value they are and round right at the end when you're kind of presenting or showing the final result. So I only round when I display it to the user, hence my round functions are over there and not in here. It's perfectly fine if you round here or round when you add them, perfectly fine. This is just how I do it. It's just because how I've been mentally trained to display information. So that's pretty straightforward. The extra flooring you would need is just 10% of your area, just to account for wastage, as it did say somewhere here. So 10% of that is what the extra, and just display that to 3 decimal places with round. Obviously, if you don't know what this round function does, just Google it. I did show you that in yesterday's webinar. A lot of programming is just problem solving, and if you can't solve a problem, just Google it. Someone else has probably in the same been in the same position as you, and there probably is like a Stack Overflow form on whatever problem you're facing. The last print statement is also fairly straightforward. I add the area and the extra, and then round it to 1 decimal place because that was one of the requirements. Round down as so to 1 decimal place, 2 meters squared. That's our total flooring, and we do get pretty much the same output. That being said, let's close this. No, actually, we'll keep this to the side if we do need it again. Let me just make sure chat is visible. There we go. Cool. Now, now we're going to kind of improve upon this program. And from now on, I advise you do similar things to what I'm about to do. So in industries or in quote unquote the real world, programs could be in the thousands of lines, millions of lines. So in Python, to see how long your program is, just go onto the bottom line, put your little typer thing there, and then at the bottom it tells you what line you are. So this program is roughly 12 lines. In reality, it's only 1, 2, 3, 4, 5, 6, 7 lines long. We don't count white spaces. We use white spaces just so, as like humans, we could understand it better. We could break it up better. But as when you're talking about how big is your program, you're talking about lines of code, and lines of code basically states how many actual lines of code is there in your program. So this is 3, 4, 5, 6, 7. So this is 7 lines of code. This program is only 7 lines long, even though we put our cursor here and it says 12. 12 actual lines, including white space. Otherwise, it's 7 lines long. But in the real world, programs go into the millions, millions of lines, and as you could probably imagine, it gets complicated really quickly. Now, one way to help reduce that complexity is by using comments. So comments are in pretty much all programming languages, and it's just a thing that has been implemented. So when your program runs, Python or Java or C, they don't read comments, they skip over them, and they just execute the rest of the code. So the intention of comments is just to make it so you could type like a message, so when another human is reading your code or program, they understand what's going on. So right now I'm going to show you how I would kind of comment this code. So firstly, you kind of need to mentally break down the code. So this just get length and width from the user. So now I've just made a simple comment. So comments will change color. So in Python, the way you comment is there's 2 ways of commenting. I'll show you both. For now, I'll show you one way, which is by using a hashtag. So when you have a hash at the beginning of at the beginning of a line, that basically tells Python from here on, like for this line, is a comment and to ignore it. So when Python runs this, it will ignore this line and just skip over it because it could see this hash. Now, the advantage of this, as I said, is to let other people know what your program is doing. And it's just really straightforward. So if someone were to come to my program for the first time with zero idea what it's supposed to do, they could really easily calculate. They could really easily see what's going on. So this, I'm just going to say this. Actually, it's best to keep your comments as simple and straightforward as possible. So just don't get into the habit of saying having really long comments that probably describe 1 or 2 lines. For now, just as an example, I'm showing you like 1 comment for every 1 or 2 lines. But in practice, I'll get into it in a second, you do 1 comment for every block of code. I'll get into that in a second, but for now, just as an example, this is how we're doing it. So this line is just calculate the area in meters squared. Calculate the area in meters squared. I guess we could comment this too. Print the area. Actually, to be fair, print statements don't really need comments. I'm still kind of debating if we need that there. But so calculations are basically where people kind of get stuck when you're reading someone else's code into what this code is doing. So over here we could just say calculate extra flooring needed. Now with these 3 really simple comments, anyone who looks at the code should fairly easily be able to tell you what the code does and how it does it. And yeah, that's the point of comments. Comments just to break down code so other humans could understand them fairly well. So by just to show you, if I do run this, it does run the exact same. Let's use the values from up top. 1,520. There we go. Same output. Just to show you that Python just skips over these lines when it runs. Another way of doing a comment is by using 3 quotation marks in a row, like so. Now what this does is this allows you to make a block comment, and this also allows people to make fancy comments. So one use I've seen a lot of people do for this type of stuff is something like so. Just be all fancy like that. Let's go to the middle-ish and just say made by Amrit. There we go. So let's cut this and let's put this at the top. And whenever someone sees this code, they can see this comment, oh, it was made by someone called Amrit. So this is what we call a block comment. This comments out multiple lines. And obviously it starts where you have 3 quotation marks and it ends where you have 3 quotation marks. It's also fairly straightforward like normal comments. So this is for 1 line. By the way, you could also have comments at the end of a line saying length, I guess, as a comment, and Python will only skip from that hashtag onwards. If you have 3 quotation marks or 3 speech marks, Python would skip as many lines as it takes for you to end it with 3 quotation marks. So if I do get rid of this, you'll see that all of this turns green because Python considers that now as a comment. Let's put the 3 quotation marks back, and now Python treats this as a comment. So if we run this again, save it, same values, I guess. There we go. Python skips it. It doesn't affect Python in any shape, matter, or form. So this is just for humans, just so other humans understand your code and what's actually going on. And that was comments. So comments are useful for just under other human beings, and I really emphasize human beings because it's nothing to do with the programming language. It's just so other people can understand what you've done and what your intentions were or whatever. And yeah, that's comments. So from now on, I highly advise you use comments in any program you make, whether that be a challenge I set or any of your own projects. Use comments. It also helps you out a lot when you come back to your code. I have a lot of projects that I have saved on my computer, and now when I open them up and I look at the code, I just think to myself, oh, well, I don't understand what I've done way back when. If I had added comments back then, maybe it would be a different story, and I understood what old me was thinking, previous me was thinking. So comments is really useful for other people and yourself, just so if you do come back to this, you fully understand what's going on. That being said, we can close this now, and we will. Is this me or is this smaller? No, same size. Cool. So now today, so that's one of the things I have ticked off of my list of what we will be going over today. So if you do have any questions, do put it in the chat. I am looking. I do have the chat open, so if you do have any questions, feel free. So the next thing we will be looking at is another way, like comments, is used to make lives for us humans a lot easier. Or I should say programmers a lot easier. And they're called methods. Now, I guess all programming languages have 2 different types of methods. We'll be going over both, and I say 2 different types. There's only one thing that differentiates them, and it's not really obvious at a first glance. That being said, all a method is a chunk of code, just kind of separated from your main piece of code. It's probably better to show you an example. So in Python, in order to make a method, you use the keyword def. Def for define, or I'm pretty sure it's define. So def, obviously def changes color because it is a keyword in Python. So def, and then you create your name for your method. If I were to, when I first started programming, the way I kind of thought of methods were machines. You give it some information, it does something with the information and gives you something back. You don't know how it does it, you don't know what processes it used to do whatever it does, but you know you give it something and you get something in return, generally speaking. That's a really specific type of method. There are 2 types called functions and procedures. Procedures, imagine them as machines that can take in inputs but don't give you anything back. And functions are stuff that you generally give things to, but it also, yet again, it's not necessary. So you can give information and it will give you something back. So let's kind of understand what I just said. So in Python, to create a method, you use the keyword def, and then you give it its name. So in this example, I guess I'll just make a method that prints out a chunk of information. So I'm going to call the method print info. Um, I don't remember if I've said this in a previous webinar, but in programming, the general way of writing method names and variable names is the first word starts off all lowercase, and then every word after that starts off with a capital letter. So if I wanted to add another word like print info of students, this is generally how a lot of people will write the variable names. This is another thing you may see a lot using underscore. It's also perfectly fine, but a lot of people tend to just start off every other word with a capital letter. So the first word stays all lowercase, and every word after that is capital. Starts with a capital letter. So def print info, and then brackets, and then a not a semicolon, a colon. So this is the basic way of making a method. Method, yet again, is just a chunk of code. In GCSE, you kind of learn that methods are used to break down a large piece of code into chunks. And that's probably the best way to explain it. So it breaks down, methods are used to break down large codes into chunks. So these brackets, we'll come back to them in a second. Now, in a lot of programming languages, you would tend to see these brackets. I'm going to call them curly brackets for now, and in a lot of programming languages, you'll see these brackets, and then you see these brackets, and then you type in whatever code you have within them. Python is different. Python, instead of using these brackets, uses indentation to kind of understand what to do and when to do it. So in Python, when you're on this line, you press enter, and as you can see, it automatically kind of indents you for you to start typing. Now, everything with this indentation level will kind of be the equivalent of being within curly brackets. So for now, I'm just going to say print. What do I print? Let's just say you print hello. Welcome. Whoops, let's put a space between them. Hello, welcome. And let's get another print statement. Print I don't know, print how are you? Just a really simple method. Now, do note, if we do run this right off the bat, nothing's going to happen. It's just going to run and just do nothing. And I'll kind of explain that in a second, because in order to activate a method, or in order to run a method, you need to what we call the method. So in this case, we do print info. I kind of forgot the O up here. Let's fix that. Print info. And after you've kind of written out what your method's name is, you do the same open and close brackets. Now if we run this, okay, there we go. It ran the method, and it did whatever was inside the method. Now, now let's talk about what these brackets are here for. These brackets have a really important job, and that is this is how you define like how to get information into the methods. So it's all good and handy that we could create methods. They're really helpful for various reasons. So if you have a piece of code that repeats itself again and again, you could put in a method, and then you could decrease like your lines of code, because you put in the method and then you just call the method again and again, rather than the whole chunk of code again and again. But that's all well and good, but how do methods communicate with each other? Now, the main reason why is using these brackets. Now, these brackets are what we call parameters. So you enter your parameters here, and that's how you communicate between kind of methods. So let me show you an example. Let's say in order for this method to work, we need a name and we need an age. Let's just say we need a name, and we need an age. Now, if we do run this, this is going to give an error. Just that's not what I wanted to click. Okay. Now, this will give an error because if you do read the error message properly, it says print info missing 2 required potential arguments, name and age. So basically, in order for this method, whoops, let's put that back to there. So in order for this method to work, you need a name and an age. But we haven't given it anything, which is why Python's freaking out and complaining about it. So we can make this even better, and we can say first name is equal to input what is your name? And then do we need surname, first name? No, that's okay. So age is equal to int input enter enter your age. There we go. So that's just a really simple thing, and then we could do first name age. Now, if you run this, this should run perfectly fine, and I'll explain it in a sec. So amrit 20. There we go. There we go. It ran and it works. Now, things to note. So a lot of people, when they first start programming, they kind of have this mindset that arguments and parameters need to be the same name, which is completely false. The entire point of parameters is you need some sort of name, and you need some sort of age. Now, when you run the method, this name could be completely different to what this says here. The entire point is that in order for this to run, you need a name and an age. And to run it, you could give it any values. You just have to be careful that you give it in the right order. So if you gave age and then name, then this would like your code in here would probably freak out because you've kind of confused something. And by the way, if you are at all confused when making a program, best way is to play around and test what you're confused with, and hopefully eventually it will make sense. So first thing to note, that these can be different. You don't have to strictly make them the same. So that was the entire point of me using first name instead of just saying name. And they can be the same. It's not required. The entire point is this method isn't going to work without these parameters, and you could give them any arguments. Like over here, I could literally just give it amrit and 20. Whoops, 20. And then over here, instead of printing this, let's just print name, and then let's just print age. So if we run this, this is just for me to show you. It doesn't matter what we type here. Oh wait, I forgot. Let's run this again. So the reason I got an error is because I'm converting it to an int immediately, and it kind of freaked out when I gave it ASDF because obviously you can't turn that to an integer. There we go. I typed in ASDF 20, and it printed out amrit 20 because obviously as parameters we're giving it amrit and we're giving it 20. Of course, if we change this to first name, and then age. Now if we run this, my name is, let's just say ASDF, and then 55, whoops, 55, and there we go, ASDF 55. So methods, for now, we won't be using them a lot until I think 4 or 5 more webinars down the line. But this is really important to know how to use methods and how to play around with them. Now, as I said earlier, there are 2 types of methods called procedures and functions. The only thing with the method is you can return information. So you could return age, let's say plus 20. This is just a really basic example, and all we're going to do here is print whatever this goes back. Now, the way you kind of need to think about this is when you return a value, wherever you call that method, it will give back that value. So you could also instead of have it being print, it could also be a new age is equal to, whoops, let's make that one word. New age is equal to this method, it's equal to whatever this method gives back. So this return, what return does is it gives back information wherever you call it. So us printing it is just the same thing as, well, instead of storing it, we just immediately print it out. So if we were to run this, run module, okay, let's just do ASDF, and then 60. And there we go. So it prints ASDF because that's the name we gave it. It prints 60 because that's the age we gave it. And then it prints 80 because it does age plus 20, so 60 plus 20, which then goes into this print statement, and then it just prints 80. Hopefully that kind of makes sense. The only way you're going to understand it more is playing around with it. And it's 38, so we have been live for give or take 36 minutes. So hopefully this gives us enough time to cover our last topic. If you do have any questions, do leave them in the chat. But for now, that's all we're going to do on methods. Just to quickly finish off. So the difference between procedures and functions is that procedures don't have a return statement and functions do. You can think of it mathematically. Functions generally are in the form of f of x is equal to something. And f of x generally gives you an output when you give it some value x. On the other hand, procedures is just a chunk of code. It's just a procedure. So procedure is just like some rules you have to follow. And that's, so if you do think of them in their literal meaning, it should also make sense. So procedure is just a chunk of code that runs, doesn't give you anything back. Functions give you something back, and you could do something with whatever they give back. Now it depends. If you give something to procedures and functions don't really change if you give them information. I could have a function without any of this, and this is still perfectly fine. Obviously, this isn't going to work because Python's going to freak out that you haven't given it name and age. Now that being said, let's get into the final topic so I could give you today's challenge. So far in Python or in coding, we've looked at how to run a program line by line, which is perfectly fine, great. What we haven't looked at is how to branch. So if some condition is met, to do something, otherwise do something else. And in pretty much all programming languages, that's called if statements or branching. Branching is a key concept in programming, and nailing this is fairly important. Now, branching is really straightforward, and I'm going to make a quick program. So let's just say a is equal to the number 5. If, and obviously if, I'll explain it in a second. So if a is equal to 5, print 5, and this is just a really basic example. We'll be building up on this example just to show you different things. So this is really straightforward. As I said, I think 2 webinars before, 1 equal sign in programming languages is assignment. So all this means is we're taking this value and we're putting it inside this A. 2 equal signs in programming languages is comparison. So we're checking if the value in A is equal to 5. If it is, then do this chunk of code. Otherwise, skip it. That's all this code does. So if we print this, run module, okay, we should see 5. But if we, let's say, make it 7, and we run this, we won't see anything because this condition isn't met. Now, there is another thing that we could do, and that's called an else statement. So all this means is if this condition is met, do this. Otherwise, do this. Otherwise, we could just say print not 5. Fairly straightforward. Run module. Okay. And now we print not 5 because this condition isn't met, and then we say else, do this condition. So logically speaking, this should make sense fairly quickly. It's really straightforward. So if this condition is met, do this, otherwise or else do this. If you just use these keywords in a sentence, it should make sense. Now do note, if you do make this 5 and then run this, only the top bubble prints because we have met this condition and we don't need to do anything else. This is going to be really important in a second, but just quick syntax for syntax is just rules and programming rules, so how your code should be written. Syntax, like if you have a syntax error, that basically means you haven't written your code properly. So when you do an if statement, you have to end it with a semicolon, and everything else has to be indented. In other programming languages, as I said earlier, you see these curly brackets, and you put your code in between here. But in Python, you use these colons, and this dictates what gets run and what doesn't get run. So that was if and else. Now there is another statement you need to know, which is elif. The best way to describe it is the combination of if and else. So literally in other programming languages, you'll see else if like this. But in Python, they've kind of combined it to elif. Elif a is equal to 6, print, let's just say print 6. We don't need to put it in quotation marks. So obviously it prints 5 because it's 5. If we do 6 and we run it, run module, okay. There we go, it prints out 6. Now, elif is also fairly straightforward. It just means else if. So it's just basically another if statement. So if this is true, run this piece of code. If not, if this statement's true, run this piece of code. Else, run this piece of code. So it's fairly, and you kind of have to follow this structure. So it has to start off with an if. Elif is optional. You don't have to use it, and so is else, but it has to be in this order. So if you do use all three, you have to start off with an if. You can only have one if. And then elif just means else if, and else just means otherwise do this. Now do note that if one condition is met, Python will not even bother checking the other conditions. So if we did do something like this, let's say 5 is less than 6. Cool. So if we were to run this, okay. No, it only prints 5, and here's why. So obviously A is 5. The first condition checks A is equal to 5. Yes, it is. It runs this piece of code, and it doesn't even bother checking the rest. Even though this is also true, A is still less than 6. So always keep that in mind. Always keep in mind which order you're doing if, elif, and then else, because you may want this on top of this, but do know that if you had this on top of this, this would run and this wouldn't run at all. So you do kind of have to think about what's going on in that regard. So Python and pretty much all programming languages will skip all other else, if, or else statements if one condition is met. So as soon as that condition is met, it runs this, and it doesn't even bother checking the rest. It just goes over here and just runs whatever is afterwards. So we could do print done, and we could run this, okay, and then it'll print 5 and then done. So it prints 5, it follows this chunk of code, skips all of this, and then prints done. Hopefully that makes sense. If statements can get complex really quickly, and just as a note for just so you understand, 2 equal signs mean, actually let's do this as a block comment. Okay, so there we go. So 2 equal signs means, let's do it like this. So this means that it is comparing if it's equal. Is it equal? So 2 equal signs compares if it's equal. This is less than. Less than. Let's make another space between them. This is greater Done. These are all mathematical operations, and you can mix and match the two. So um, this is less than equal to, this is greater than equal to. What else is there? For now, that's probably all you need to know. In if statements, you could have other statements. The entire point is, if this becomes true, do some sort of activity. Another example, just so for people who saw our lecture on data types, if we have a variable called, I don't know, is over, let's just say, false. Oh no, Python, what's a capital F-A-L-S-E, there we go, false. So is over is just the first variable name I came up with to check if someone is over 18. So if we set is over to false, I'm just going to show you a really quick program. So is over is false, then we could do age is equal to int. This is fairly straightforward at this point. Input enter your age. Bang. So over here we could do if age is greater than or equal to 18, is over is equal to true. T-R-U-E. T-R-U-E, there we are, true. So all we've done so far is get the age from the user, have a variable which is type Boolean. If you don't know what that is, check out our second webinar. Second webinar. And all we've done here is if age is greater than or equal to 18, so if this person is over or equal to 18, set is over to true. This person is over the age of 18 and can probably do whatever your app wants them or your program wants them to be able to do. So that's just a condition. And then over here we could do if is over, print you are over 18, else print you are under 18. Now let's comment out all of this. Does this work in Python? Nope, it doesn't. So let's 3 there, and then 3 there. Wait, what is going on? Why is this black? That is very strange. Don't know what's going on there. Oh, did I? Is it because? Ah, there we go. Okay, yeah, that makes sense. 3 there, 3 there. There we go. So by the way, if you do have that problem, just hit Control and then slash, and that should fix it. In other languages, that's just a way of quickly commenting a brick of code. So let's comment this out. So none of this will run. This will run, and only that would run. So run module. Okay. So first it asks us for age. So note that none of this ran because obviously it's within a comment. Let's say my age is 20. There we go. You are over 18. Let's run it again just so we could enter an age less than 20. So 5. You are under 18. Now let's kind of explain quickly what went on here. So obviously we asked the user for their age as an int. Enter your age. If their age is over 18, just set this Boolean value to now true. Obviously false and true are keywords in Python because they change color. Now this is just a very key example that I quickly wanted to show, that obviously if you have Boolean variables, you could just have the variables in there, and if it's true, it will print this chunk of code. If it otherwise, obviously print the other piece of code. Now this is very useful in a lot of situations, so it saves you from doing is equal to true. Saves you from doing that because essentially what you're doing even in this example up here is Python is Python is just basically calculating whether this statement is true or false. And if it's true, it runs this code. Otherwise, it checks the next one. Is this true? Run this piece of code. Otherwise, else, do whatever. We could have, and by the way, you can only have one if and one else, but you could have, technically speaking, an infinite number of elif statements. So elif, 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 so on and so forth. You could have an infinite number of those. You can only have one if and one else. We are pretty much done time-wise for today. So hopefully this has made sense. I will be yes. So if you do want to challenge yourself, be sure to give this challenge a go. I will be sharing my answer of this code tomorrow. I will also be going through this this example tomorrow as just how I would approach it. So do tune in tomorrow just for better understanding of if and elif statements. Otherwise, if you feel confident enough, feel free to go forward and try this challenge. Yeah, it's fairly straightforward. You take in three pieces of information from the user, and based on this criteria, you do something. So you're going to have a fair few if and elif statements, but it's always good practice to do it. That being said, feel free to screenshot this. I am looking at the chat right now, so if you do have any questions, do let me know. So feel free to ask me any questions about anything we've done today. Yeah, this is today's challenge. I'm not sure if tomorrow we'll have a challenge. I will look into that in a second. But yeah, so do take a screenshot if you feel confident enough. Go for it. Try doing this challenge. If you're not able to do it, don't worry. I'll be going over it tomorrow, and I'll be going over another example tomorrow as well. I don't see any questions, and we're pretty much all out of time for today. So thank you everyone so much for watching. If you're watching on YouTube, do join in live just so you could ask me questions if you do have any questions. And definitely do join in live tomorrow. So if you do have any questions about if statements, you could get them answered, just because it is a pretty important part of coding. So thank you everyone so much for watching. I don't see any questions, so I will see you in tomorrow's webinar. Bye-bye.